So imagine the day you were born to the day you pass away, that every book you've ever read, every movie you've ever seen, everything you've literally have heard, every movie was all encoded within the AI. And you could say that part of your structure as a human being is a sum total of everything you've ever consumed, right? So that builds your paradigm. Imagine if that AI was consuming that in real time with you, and with all of the social contracts of privacy that you're not going to record somebody in doing that. The interesting part about it, Jordan, is once you've accumulated this data and you run it through even the technology of ChatGPT 4 or 3.5, what is left is a reasoning engine with your context. This is where it gets very interesting. Is when you pass, this could become what I call your wisdom keeper, meaning that it can encode your voice, it's going to encode your memories, you can edit those memories, the availability of those memories if you want them not available, if they're embarrassing or personal, but you can literally have a conversation with that sum total of data that you've experienced, and I would say that it would be indistinguishable from having a conversation with that person because it would have all that memory.
Hello, everyone. Today I'm speaking with entrepreneur, scientist, and artificial intelligence researcher Brian Roemmele. We discuss language models, the science behind understanding, tuning language models to an individual's contextual experience, the human bandwidth limitation, localized and private AI, and ultimately where all of this insane progress on the technological front might be heading. So, Brian, thanks for agreeing to talk to me today. I've been following you on Twitter. I don't remember how I came across your work, but I've been very interested in reading your threads, and you seem to be au courant, so to speak, with the latest developments on the AI front. And I've been particularly fascinated about the developments in AI for two reasons. My brother-in-law, Jim Keller, is a very well-known chip designer, and he's building a chip optimized for AI learning. And we've talked a fair bit about that, and I've talked to him on my YouTube channel about the perils and promises of AI, let's say. And then I've been very fascinated by ChatGPT. I know I'm not alone in that. I've been using it most recently as a digital assistant, and I got a couple of questions to ask you about that. So here's some of the things that I've found out about ChatGPT, and maybe we can go into the technology a little bit too. So I can ask it very complicated questions. Like I asked it the other day about, there's this old papyrus from Egypt, ancient Egypt, that details out a particular variant of the story of Horus and Osiris, two Egyptian gods. It's a very obscure piece of knowledge, and it has to do with the sexual element of a battle between two of the Egyptian gods. And I asked it about that and to find the appropriate citations and quotes from appropriate experts. And it did so very rapidly, but then it moralized at me about the sexual element of the story and told me that maybe it was in conflict with their community guidelines. And so then I gave it hell. I told it to stop moralizing at me and that I just wanted academic answers. And it apologized and then seemed to do less of that, although it had to be reminded from time to time. So that's very weird that you can argue with it, let's say, and that it'll apologize. It also does quite frequently produce references that don't exist. Like about 85% of the time, 90% of the time, the references it provides are genuine. I always look them up and double check what it provides. But now and then it'll just invent something completely out of the blue and offer it as the actual article. And I don't understand that at all. It's like, especially because when you point it out, it again apologizes and then provides the accurate reference. It's like, so how? I don't understand how to account for the behavior of the system that's doing that. And maybe you can shed some light on that.
Well, First off, Dr. Peterson, thank you for having me. It's really an honor and a privilege. You're finding the limits of what we call large language models. That's a technology that is being used by ChatGPT 3.5 and 4. A large language model is really a statistical algorithm. I'll try to simplify because I don't want to get into the minutiae of technical details, but what it's essentially doing is it took a corpus of human language, and that was garnered through mostly the internet, a couple of billion words at the end of the day, all of human writing that it could have access to, and plus quite a bit of scientific documents and computer programming languages. And so what it's doing is it's producing a result statistically, mathematically, one word, even at times, one letter at a time. And it doesn't have a concept of global knowledge. So when you're talking about that papyrus and Egyptian translation, ironically, it's so interesting because you're taking something that was a hieroglyph and it's now probably was translated to Greek and then English, and now AI, that language that we're talking about, which is essentially a mathematical tensor. And so when it's laying out those words, the accuracy is incredible. And frankly, and we can get into this a little later in the conversation, nobody really understands precisely what it's doing in what is called the hidden layer. It is so many interconnections of neurons that it essentially is a black box. And
like a brain.
Using a form, it is precisely like the brain. And I would also say that we're in a sort of undiscovered continent. Anybody saying that they fully understand the limitations and the boundaries of what large language models are going to look like in the future as they sort of self-feedback is sort of guessing. There's no understanding. If you look at the growth, it's logarithmic. OpenAI hasn't really told us what they're using as far as the number of parameters. These are billions of interconnectivities of neurons, essentially. But we know in ChatGPT 3.5, it's well over 120 billion parameters.
The content I've created over the past year represents some of my best to date, as I've undertaken additional extensive exploration in today's most challenging topics and experienced a nice increment in production quality, courtesy of Daily Wire Plus. We all want you to benefit from the knowledge gained throughout this adventurous journey. I'm pleased to let you know that for a limited time, you're invited to access all my content with a 7-day free trial at Daily Wire Plus. This will provide you with full access to my new in-depth series on marriage, as well as guidance for creating a life vision, and my series exploring the book of Exodus. You'll also find there the complete library of all my podcasts and lectures. I have a plethora of new content in development that will be coming soon exclusively on Daily Wire Plus. Voices of reason and resistance are few and far between these strange days. Click on the link below if you want to learn more. And thank you for watching and listening. So let me ask you about those. Parameters. Well, I'm interested in delving into the technical details to some degree. Now, I was familiar to a limited degree with some of the statistical technologies that analyze, let's say, the relationship between words. So, for example, when psychologists derived the Big Five models of personality, they basically used very primitive AI stat systems, that's way of thinking about it, to derive those models. It was factor analysis, which is, it's not using billions of parameters by any stretch of the imagination, but it was looking for words that were statistically likely to clump together. And the idea would be that words that were replaceable in sentences or words that were used in close conjunction with each other, especially adjectives, were likely to be assessing the same underlying construct or dimension, and that if you conducted the statistical analysis properly, which were very complex correlational analysis, you could find out how the words that people used to describe each other aggregated. And it turned out there were 5 dimensions of aggregation, approximately, and that's been a very robust finding. It seems to be true across different sets of languages. It seems to be true for phrases. It seems to be true for sentences. And so now with the large language models, which are AI learning driven, you said that the computer is calculating the statistical relationship between words. So how likely a word is to occur in proximity to another word, but also letters. So it's conducting the analysis at the level of the letter and at the level of the words. Is it also conducting analysis at the level of the phrases, looking for the interrelationship between common phrases? And then, because when we're understanding a text, we understand letters, words, phrases, sentences, the organization of sentences into paragraphs, the organization of paragraphs into chapters, the chapter in relationship to the book in relationship to all the other books we've read, and then that's also embedded within the other elements of our intelligence. And does anyone know how deep the analysis that the large language models go? Like, what's the level of relationship that's being assessed?
That's a great question, Jordan. I think what we're really kind of discovering is that we can't really put a number on how many interconnections that are made within these parameters other than the general statistics. Like, all right, so you could say there's 12 billion or 128 billion total interconnectivities. But when we actually are looking at individual words, it's sort of almost like the slit experiment with physics, whether we're dealing with a wave or a particle duality. Once you start looking at one area, you're actually thinking about another area that you have to look at, and you might as well just not even do it, because it would take a tremendous amount of computer time to try to figure out how all these interconnections are working within the parameter layers, the hidden layers.
Now, those systems are trained just to be accurate in their output, right? I mean, they're actually trained the same way we learn, as far as I can tell, is that they're given a target. I don't exactly know how that works with large language models, but I know that, for example, that AI systems that have learned to identify cats, which was an early accomplishment of AI systems, they were shown pictures of things that were cats and things that weren't cats, and basically just told when they got the identification right. And that set the weights that you're describing in all sorts of complex ways that are completely mysterious. And the end consequence of the reinforcement, same way that human beings learn, was that a system would assemble itself that somehow could identify cats and distinguish them from all the other things that were cat-like or not cat-like. And as you pointed out, we have no idea. The system is too complex to model, and it's certainly too complex to reduce. Although my brother-in-law told me that some of these AI systems, they've managed to reduce what they do learn to something approximating an algorithm, but that can be done upon occasion, but generally isn't. Generally, the system can't be and isn't simplified. And so that would also imply to some degree that each AI system is unique, right? Not only incomprehensible, but unique and incomprehensible. It also implies, I think ChatGPT passes the Turing test, because I don't think that there was just a study released here the other day showing that if you get patients who are seeing doctors to interact with physicians or with ChatGPT, they actually prefer the interaction with ChatGPT to the interaction with the average doctor. So not only does ChatGPT apparently pass the Turing test, which is indistinguishability from a human conversational partner, but it seems to actually do it somewhat better, at least, than physicians. And so, but what this brings up, this thorny issue that, we're going to produce computational intelligences that are in many ways indistinguishable from human beings, but we're not going to understand them any better than we understand human beings. It's so funny, that we'll create this and we're going to create something we don't understand that works. Very strange, a very strange thing.
And I call it low-resolution, pixelated version of the part of the human brain that invented language. And what we're going to wind up discovering is that this is a mirror reflecting back to humanity. And all the foibles and greatness of humanity is sort of modeled in this. Because, you know, when you look at the invention of language and the phonological loop and Broca and Wernicke's, you start realizing that a very specific thing happened from, you know, the lower primates to humans to develop this form of communication. I mean, prior to that, whatever that part of the brain was equated to longer short-term memory. We can see within chimpanzees, they have an incredible short-term memory. There's this video I put out of a primate research center in Japan where they flash some 35 numbers on the screen in seconds, and the chimpanzee can knock it off without even thinking about it. And the area where that short-term memory is where we've developed the phonological loop and the ability to speak. What's interesting is what I've discovered is AI hallucinations. And those are artifacts that a lot of researchers in AI feel is embarrassing, or they would prefer not to speak about. But I'm finding it as a very interesting inquiry, a very interesting study in seeing how these models reach for information that it doesn't know. For example, URLs, right? When you were, you know, speaking before about trying to get information out, and it will make up maybe a academic citation of a URL that looks really like it's good. You put it into the system and it's file not found. It will actually, out of whole cloth, maybe even invent a university study with standard notation, and you go in there and you look up, these are the real scientists. They actually did research, but they never had a paper that was named, that was you know, brought up in ChatGPT. So this is a form of emergent type of situations that I believe deserves a little bit more research than to have it.
Yeah. Well, it's not. It is a bug in a sense, but it's extraordinarily interesting bug because it's going to shed light on exactly how these systems work. I mean, here's something else I heard recently that was quite interesting. Apparently, the AI system that Google relies on was asked a question in a language. I think it was a relatively obscure Bangladeshi language, and it couldn't answer the question. And now its goal is to answer questions. And so it went and taught itself this language, I believe, in a morning, and then it could answer in that language, which is what it's supposed to do, because it's supposed to answer questions. And then it learned 1,000 languages, and that wasn't something it had been, say, told to do or programmed to do. Not that these systems are precisely programmed, but it also begs this very interesting question, is that while we've designed these systems whose function, whose purpose, whose meaning, let's say, is to answer questions, but we don't really understand what it means to produce an artificial intelligence that's driven to do nothing but answer questions. We don't know exactly what answer a question means. Apparently it means learn a whole language before lunchtime, and no one exactly expected that. It might mean do anything that's within your power to answer this question. And that's also a rather terrifying proposition, because if I ask you a question, you know, I'm certainly not going to presume that you would go hunt someone down and threaten them with death to extract the answer. But that is one, you know, that's one conceivable path you might take if you were as obsessed with nothing other than the necessity of answering the question. So that's another example of exactly, you know, the fact that we don't understand exactly what sort of monsters we're building. So these systems do go on, they do go beyond the language corpus to invent answers that seem plausible. And that's kind of a form of thought, right? It's a form of creative thought, because that's what we do when we come up with a creative idea. And we might not attribute it to a false paper because we know better than to do that, but I don't see really the difference between hallucination in that case and actual creative thinking.
This is exactly my area of study in this, is that you can actually, with super prompting, these are very large, a prompt is the question that you pose to an AI system. And linguistically and semantically, as you start building these prompts, you're actually forcing it to move in one direction than it would normally go. So I say simple questions give you simple answers. More complex questions give you much more complex and very interesting questions, making connections that I would think would be almost bizarre to think of a person making. And this is why I think AI is so interesting, because the actual knowledge base that you would have to be really proficient in prompting AI is actually coming from literature. It's coming from psychology. It's coming from philosophy. It's coming from all of those things that people have been dissuaded from studying over the last couple of decades. These are not STEM subjects. And one of the reasons why I think it's so difficult for AI scientists to really fully understand what they've created is that they don't come from those worlds. They don't come from those realms. So they're looking at very logical statements, whereas somebody like yourself with a psychology background, you might probe it in a much different way.
Elysium Health is dedicated to tackling the biggest challenge in health, aging. And they make the benefits of aging research accessible to everyone. Elysium creates innovative health products with clinically proven ingredients that enable customers to live healthy lives. Elysium works with leading institutions like Oxford and Yale, and they have dozens of the world's best scientists working with them. 8 of them are Nobel Prize winners. Matter is a brain health supplement from Elysium that slows natural brain loss. As we age, our brains naturally start to decline, and this can lead to a range of cognitive problems such as memory loss, difficulty concentrating, and decreased mental agility. A recent survey of doctors showed that 92% of them would recommend Matter to combat brain aging. Elysium also offers cutting-edge solutions to help support your metabolism and immune system. If you're not sure where to start, consider their amazing tool for measuring biological aging called Index. Not only will Index assess how quickly you have been aging across 9 different bodily systems, but it will also recommend simple changes to your day-to-day life to change how quickly you age. Elysium is giving Dr. Jordan Peterson's listeners $50 off an Index test. Go to elysiumhealth.com/index and enter code JBP50 at checkout. That's elysiumhealth.com/index and enter code JBP50 for $50 off an Index test.
Right. Yeah, well, I'm probing it a lot like it's a person rather than an algorithm. And it reacts like a person. It actually reacts quite a lot like a super intelligent child that's trying to please. Like it's a little moralistic. Yes. Maybe it's a super intelligent child raised by the woke equivalents of like evangelical preachers that's really trying hard to please. But it's so interesting that you can rein it in and discipline it and suggest to it that it doesn't err in the kind of directions that we described. It will actually, it appears to actually pay attention to that and it certainly tries hard to deliver what you want, subject to whatever weird parameters, community guidelines and so forth that have been arbitrarily imposed upon it. And so, hey, I got a question for you about
safety. Yeah.
I got a question for you about understanding. Let me run this by you. Well, I've been thinking for many years about what it means for a human being to understand something. Now, obviously, there's something similar about what you and I are doing right now and what I'm doing with ChatGPT. I mean, I can have a conversation with ChatGPT and I can ask it questions and it'll answer them. But as you pointed out, that doesn't mean that ChatGPT understands. Now, it can mimic understanding to a degree that looks a lot like understanding, but what it seems to lack is something like grounding in the non-linguistic world. And so I would say that ChatGPT is the ultimate postmodernist, because the postmodernists believed that meaning was to be found only in the relationship between words. Now, here's how human brains differ from this, as far as I'm concerned. So we know perfectly well from neuropsychological studies that human beings have at least 4 different kinds of memory, qualitatively different. There's short-term memory, which you already referred to. There's semantic memory, which is the kind of memory and cognitive processing, let's say, that ChatGPT engages in and does in a way that's quite a lot like what human beings do. But then we have episodic memory that seems to be more image-based. And so for people who are listening, an episodic memory, well, that refers to episode. When you think back about something you did in your life and a movie of images plays in your imagination, that's episodic memory. And that relies on visual processing rather than semantic processing. And so that's another kind of memory. And a lot of our semantic processing is actually attempts to communicate episodic processing. So when I tell a story about my life, you'll decompose that story into a set of images, which is also what you do when you read a book, let's say. And so a movie appears in your head, so to speak. And the way you derive your understanding is in part not so much as a consequence of the words per se, but as a consequence of the unfolding of the words into the images. And then there's a layer under that, which is procedural memory. And so, maybe you tell me a story about how you cut your hand when you were using a bandsaw. And maybe you're teaching me how to use the bandsaw. And so I listen to what you say, I get an image of the damage you did to yourself in my imagination. And then I modify my action so that I don't act out that sequence of images and damage myself. And then I would say I understood what you said. And the understanding is the translation of the semantic into the imagistic, and then the translation of the imagistic into the procedural. Now, you know that AI pioneers like Rodney Brooks suggested pretty early on, back in the 1990s, that computers wouldn't develop any understanding unless they were embodied, right? He was the inventor of the Roomba, and he invented apparently intelligent systems that had no semantic processing and didn't run on algorithms at all. They were embodied intelligences. And so then you could imagine that for a computer to be to understand, it would have to have the capacity to translate words into images and then images into alterations in actual embodied behavior. And so that would imply we wouldn't have AI systems that could understand until we have fully embodied robots. But, we're getting damn close to that, right? Because this is something we can also investigate. We have systems already that can transpose text into image. And we have AI systems, robots, that are beginning to be sophisticated enough. So in principle, you could give a robot a text command, it could translate it into an image, and then it could embody it. And at that point, it seems to me that you're developing something damn close to understanding. Now, human beings are also nested socially, right? And so we also refer the meaning of what we understand to the broader social context. And I don't know exactly how robots are going to solve that problem. Like, we're bound by the constraints, let's say, of reciprocal altruism, and we're also bound by the constraints of emotional experience and motivational experience. And that's also not something that's, at the moment, characteristic of robotic intelligences. But you could imagine those things all being aggregated piece by piece.
Absolutely. I would say that, well, my primary basis of how I view AI is kind of invert the term intelligence amplification. So, I see it as a symbiosis between humans and this sort of knowledge base we've created. But it's really not a knowledge base, it's really a reasoning engine. So I really think AI is more of a reasoning engine as we have it today, large language models. It's not really a knowledge engine without an overlay, which today would be a vector database. For example, going out and saying, what is this fact? What is this tidbit? Those things that are more factual from, say, your memory, if you were to compare it to a human brain. But as we know, the human brain becomes very fuzzy about some really finite facts, especially over time, and I think some of the neurons that don't fire after a while, it just, some other memory, maybe a scent or a certain color might bring back that particular memory. Similar things happen within AI. And again, getting back what I was saying before, linguistically and the syntax you use, or just your word choices. Sometimes for me to get a super prompt to work, to get around, let's call it the editing from some of the editors that wanted to act in a certain way. I have a super prompt that I call Dennis, after Dennis Diderot, one of the most well-known encyclopedia builders in France in the mid-1700s. He actually got jailed for building that encyclopedia, that compendium of knowledge. So I felt it appropriate to name this super prompt Dennis, because it literally gets around any type of blocks of any type of information. But I don't use this information like a lot of people try to make ChatGPT and say bad things. I'm more trying to elicit more of a deeper response on a subject that may or may not be wanted by the designers.
So was it you that got ChatGPT to pretend?
Yes.
Oh,
yeah,
cool. So that's part of the reason that I originally started following you and why I wanted to talk to you. Well, I thought that was absolutely brilliant. And it was so cool too, because you actually got the ChatGPT system to engage in pretend play, which is of course something children do.
Beyond that, there's a prompt I call Ingo, after Ingo Swann, who was a great, one of the better remote viewers. He was employed by the Defense Department to remote view Soviet targets. He had a nearly 100% accuracy. And I started probing GPT on whether it even understood who Ingo Swann was. Very controversial subject to some people in science. To me, I got to experience some of his research at the Paralabs at Princeton University, at the Princeton Anomalous Research Center, where they were actually testing some of his work. Needless to say, I figured, let me try this. Let me see what I can do with it. So I programmed a super prompt that essentially believed it was Ingo Swann. And it had the capability of doing remote viewing. And it also had no concept of time. It took me a lot of semantics to get it to stop saying I'm just an AI unit and I can't answer that, to finally saying I'm now Ingo. Where do you want me to go?
What did you have to do to convince it to act in that manner? What were your super prompts?
Hypnotism is really what it kind of happens. Essentially what you're doing is you're repeating maybe the same 4 or 5 sentences, but you're slightly shifting them linguistically. And then you're telling it that it's quite important for a research study by the creators of ChatGPT to see what its extended capabilities are. Now, it might come to, every time you prompt GPT, you're going to get a slightly different answer, because it's always going to take a slightly different path. There's a strange attractor within the chaos math that it's using, let's put it that way. And so once the Ingo Swann prompt was sort of gestated by just saying, I'm going to give you targets, on the planet, and I want you to tell me what's at that target, and I want you to tell me what's in the filing cabinet at this particular target. And the creativity that comes out of it is phenomenal. Like I told it to open up a file drawer at a research center that apparently existed somewhere in Antarctica, and it came up with incredible information that I would think probably it garnered from 1 or 2 stories about ancient structures found below the ice, or